Everybody, so we're going to start with hi everybody. I'm going to turn off my video, but I'm going to move my microphone so you can hear me a little bit better. All right, 5.1, solving systems of equations by graphing. Okay, so right away, okay, we're going to be doing systems, which means you're going to be doing more than one equation. And when you do more than one equation, we're going to see where they intersect. So when you stop and think about it, where they intersect or where they run into one another, let's see. We could have a few different scenarios, right? So two lines can intersect, right? Okay, at one point. A line, and then you could flop a line right on top of it. And so they would share all points. So we would call this the identity. Or they could be parallel. That means they would never intersect, so there would be no solution. So the first step that I want you to practice is, given a set of ordered pairs, is it a solution to the system? Okay, so I'm going to give you 2, 5, and I want you to tell me whether this is a solution to this system of linear equations. So here is the key. You have to plug it in to both of these and make both of these true. So the X goes in for the X, friends, and the Y goes in for the Y. Okay, so here we go. So I'm going to plug 2 plus 5 equals 7. Is that a true statement? Yep. Okay, so this one is good, but I got to keep going. So 2 times 2 minus 3 times 5, does that equal negative 11? Well, this is 4 minus 15 equals negative 11. Is that true? It is. So this would be a yes. All right, now you try. Negative 2, 0, y is equal to, it might look, so this is in slope-intercept form, which is fine, not a big deal. Okay, so I want to plug in the x for the x, whoops, sorry about that, and the y for the y. All right, so here we go on the first one. 0 equals negative 2 times negative 2 minus 4. Well, that is 2 negatives make a positive, and that 0 equals 0. That's good. All right, the next one, 0 equals negative 2 plus 4. That would be 2. Ooh, no, sad face. So this answer would be no. This is not a solution. So you can't have one and not the other, okay? So that's the first step, okay? The second part is looking at a graph and then estimating where they intersect. So we're going to do 2 graphs, okay? So I'm actually going to do, I'm going to do this exact, these exact graphs, okay? So I'm going to take, I'm going to give you this, and I'm going to do this exact set of points here, okay? So I'm going to take x plus y equals 7. And here's why I want to do that. I want to show you, number one, I'm going to show you how it intersects here. Number two, I want to show you how you can graph it in no matter what form. So I'm going to use my, first of all, I'm going to highlight the x and y intercepts, okay? Actually, I probably should have put that in orange, shouldn't I? Since I let, okay, so here we go. I'm going to, the y-intercept is 7. 1, 2, 3, 4, 5, 6, 7. And the x-intercept is 7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to take that and I am going to take my handy dandy ruler because I want to make sure I'm really accurate here. Okay, there we go. All right, and my next one is 2x minus 3y equals negative 11. Ooh, that one's not so nice. Let's see. Negative 3y equals negative 11. Divide by negative 3. Well, 11 divided by 3, that's 3 and 2/3, so that's 3 and 2/3, so 3 and a little bit, 1, 2, 3, and almost to 4. So I'm going to estimate a little bit. All right, what about the 2? 2x equals negative 11. Divide by 2, x equals negative 5.5. 1, 2, 3, 4, 5.5. All right. Oh my gosh, look at that. Okay, now friends, what does it look like? Okay, where did I intersect? Right there. What is this point? Well, let's see, that's 1, 2. 1, 2, 3, 4, 5. Wait a minute, that's what we calculated. Okay, so you need to graph your lines and then see where they intersect, friends. Okay, to check your work, you could always go back and plug that in. But here's the rub for this. Here's the sad face. You know, we had to do a couple fractions. Is it possible that maybe your graph didn't exactly hit there? Absolutely. So is this the most accurate way to do this? Not really. So this is one way, but we're going to work on in the next couple sections a way that we can definitely find out exactly, okay? All right, so this was in standard form. Let's do this one. Now remember, negative 2, 0 was not a solution. So let's see if we can find out the solution. But this is in the form of y is equal to mx plus b. So you know what? I don't even have to do anything. In fact, I'm going to highlight my y-intercept there. But then, friends, my x-intercept, I don't have an x-intercept. What do I have? I have the slope. That's right. I have the slope. So when I graph this, I need to graph a negative 4, 1, 2, 3, 4. And then I need to count my slope. So how do I do a slope? Negative 2 over 1. So that's down 2 over 1. Sorry, I hit a dot there. Okay. All right, let's do my second one. My second one is x plus 4. Okay, what's my y-intercept? You're right, it's 4. So I'm going to go ahead and graph 4. 1, 2, 3, 4. Okay, what's my slope? What's the number? Oh yeah, it's a 1. So I would go from my y-intercept up 1 over 1. Maybe do one more, up 1 over 1, just to make sure. Ooh, see what I mean here? Ooh. Give me an estimate. What do you think, friends? 1, 2, 3, negative 3.5, comma, and 0.5? Be my best guess. Now you might say, how do you know? Well, I could put it back in there into the equation and check. And if I do, will I get those answers? But you know what? I know that I graphed this right, correct? Negative 4, and I went down 2 over 1. I'm right there. 4 up 1 over 1. So I graphed it right, maybe not exactly. I could always plug this back in and do a double check. but I have a feeling that it's not quite right. But let's see. Let's see. Where's my calculator? All right. And I need a sticky note. All right, so technically if I wanted to check, I would need to go y is equal to -2 times -3.5 minus 4, right? And this would be a 0.5, right? Okay, so let's see. -2 times -3.5 minus 4, and I get 3. Yikes. That's not quite right, is it? Did I do it right? -4, and I went down 2 over 1. This one I went up 1 over 1. Maybe I didn't quite, I might have been off a little bit there, right? I could have been off a little bit. So you know what? I'm going to check to make sure. What ends up being is that I look at each value and see how you've done. And if you're not quite right, that could be okay too. So I wanted to show you, number one, it's a great review of how to graph. Practice more on that and then how to solve it algebraically. Thanks.